When dealing with quantitative data, it's often necessary to classify it in some way so it's more useful or usable. Because oftentimes we might have many different data points or different data values that we're trying to understand. And by many, this could mean 100, 1,000, 10,000, many different data points. So looking at all those individual values might not be the best use of your time. So there are a few different methods that I want to outline briefly. Equal intervals, quantile breaks, and natural breaks. The first, equal intervals, is where you take the full range of possible values, so not necessarily the values associated with the data you have, but the hypothetical range of values that you could have. So if you're measuring something and you know where the lowest values would be, where the highest values would be, you take that range, so that difference between the lowest and the highest values you could possibly have before even looking at your data, and then you divide those into equal parts. So we're not even looking at our data yet, but looking at that possibility, that number line of possible values that you could have. So you want the same range, so the same size for each class in terms of the number of values in each class or grouping. So my example here is, if you're taking the numbers 1 through 20, you're going to make some sort of measurement, or you have some sort of count or some quantitative values that could only fall between the values of 1 and 20. Maybe if you want 4 different classes or 4 different groups, you want them to be 1 to 5, 6 to 10, 11 to 15, and 16 to 20. So this would be equal intervals with 4 different classes. You can pick any number of classes and it would just be dividing up that range of possible values equally. So the key when remembering equal intervals is that this is based on the possibility. So the intervals themselves are equal, the class size, so that range of values that can be grouped together, that's what's equal. What's not necessarily equal is what values, the numbers of values that go into them. So you may have some class or some group that have many observations in them, like perhaps you have almost all of your values fall between 1 and 5, and maybe only a couple fall in 11 to 15. That's possible with equal intervals. So you can have some of your classes, some of your groupings that have many of your values in them, because you're not even looking at your values when you start. You're just looking at the possibility and defining those intervals equally, and then seeing how many fall into each grouping that you've set up. So you can have some with many, some with none, or very few. And we have kind of 2 approaches that we take. The first is that we base it on the range. So like I described, that's where you take the difference in magnitude between the largest and smallest values that you have. So looking at your values, find the smallest, find the largest, take that range, cut it up into however many equal parts that you want. So you might want 4 groupings, you might want 5, you might only want 3, you might want 10. So you take that range and just find what ranges, what smaller ranges of values make up, each of those 10 equal interval sized groups. Or you could not base it on range. So the exact range isn't used. You may have a convenient or practical interval or width that's used. So, you may, know something about the data without having looked at what the highest and lowest values are, and you may use those. Like you may know an exam score could range between 0 and 100 without looking at what the minimums and the maximum values are, so what that actual range is. You don't know what the smallest value is. You don't know what the largest is. But you can then take whatever values, so 0 to 100, split them into, maybe 10 different groupings, and then look at the values and start putting them in. So that's equal interval, where the possibilities are what we use to define those equal sized groupings, where we have our actual data values that then fit into them and allow the possibility of many values or very few values or somewhere in between in each grouping. So a quick example, let's assume a range of possible values between 1 and 32. And I have a few values listed here. If I wanted to split these into 4 categories, which would we have grouped together? So I want 4 categories, 4 groups, 4 classes, and 1 to 32 is my possibility. So take a moment and pause the video if you'd like. Think about which numbers would be grouped together to make up this, this equal interval between 1 and 32 with 4 different groupings. And then, maybe once you've thought about it, continue on and we'll see how they group together. So in this case, we have groupings, we want 4 between 1 and 32. So we have 8 as, our kind of cutoff. So, our first group would be numbers 1 through 8, and then 9 through 16, then 17 through 24, and then 25 through 32. And you can see that played out here. We have our first group 1 through 8 that has 7 different values in it. Our second group has nothing at all. So 9 through 16, no values. Then the next grouping has 3 values, and that final grouping has 2. So this is an example using equal intervals. So what do you notice about these? Whether there's many, whether there's few, the way the numbers happen to fall into these. So we'll reiterate that one of these groups has no values, and that some groups have more and some have fewer. And this is a possibility with equal intervals. Now the next type is quantile breaks. So what we do here is we have the full range of observed values that we divide equally. So this can be easily confused with equal intervals, because with equal intervals, we think of either the possibility or the actual range and use that to form equal groupings. With quantiles, we're going to try to get groupings or classes that have the same number of observations, the same number of data points or data values in each class. So where before with equal intervals, we could have a group with many or a group with few or even a group with none, that's not possible with quantile breaks. So we want all classes to have roughly the same number of values in each. And the only reason we would not have the same number in each is if we chose groupings where we couldn't, based on the number of data points, we couldn't split them up equally. So there might be small differences, but generally the numbers of values in each group will be roughly the same. So we basically look at our range of values. So if we want 4 categories from the numbers below, what would be grouped together? Again, you can stop this. You can take a look at the numbers, see how you think they're going to be grouped, and compare to what I put forward. But look at the range of values here. Count up the number of values that we have and think, how we're going to get 4 different groups, 4 categories from this classification. So continuing on, let's take a look. In this case, since we have 12 different values here, if you counted them up, you'll know we've got 12 values. I already have them in order for you. And if we take those 12 values and want 4 groups, we can easily get 4 groups of 3. And it works out nicely. Now, one thing I'll note, and I set this up so it wouldn't happen, if I had an extra 1 in here instead of some other digit. If we had 4 ones, we wouldn't separate a 1 into another category. So that would be a case in which we'd have one of these classes or one of these groups that might have more values in it than another. But still, we're generally holding to this, equal amounts in each category. So in this case, we've got 4 groups. We have them basically 3 values, 3 values, 3 values, 3 values. And I want you to take a look at the differences between how the groups, or how the values are grouped here versus how they're grouped for equal interval. Some of the same values are grouped together, but in some ways we have some big differences where we've got, say, a big jump between values in our third group. It goes 7 all the way up to 19. And then we have a jump from 23 to 30. So we've got these huge differences in some groups, whereas for our first group, we've got 1, just 3 values of 1. Or our second group, it goes 3 to 6. So not only do we have the same number of values in each group, but we also can see that we can have a big range within one of these classes or one of these groups. So that's going to be far different because the ranges in equal interval, those intervals are going to be equal sized, whereas with our quantiles, our ranges can be any size, but unlike equal intervals where we can have as few as none and as many as all of our values in any single class or group, here we have roughly the same number in each class or group. And you might hear different names for quantile breaks. You might call them thirds. In this instance, we might have quartiles because we have 4, but the broad name is quantile breaks. And here's some text noting what I just said. And then finally, we have natural breaks. This is a method where we use an algorithm, so I won't put you through what that might be. But basically, a formula or an algorithm that goes through procedurally, so looks at all your data values, tries out many different possible groupings, and finds the one that best minimizes the differences within a group or within a class. So tries to make it so all the numbers within one grouping are as much alike as possible, while trying to make the groups themselves as different from one another as possible. So it's a little more complex than these first two. You don't need to know all the details of how it's done, but know that you want the values within one group to be more alike than they are alike with another set of groups' values. And you'll notice then when we group these up, this one might be a little bit tougher to predict, and I didn't put it through any actual software, so I just kind of guessed this as to how it might turn out if we wanted, again, 4 categories from the numbers, which ones might be grouped together using a possible natural breaks method. We might come up with something like this. So every group is going to have something in it. We can end up with groups that have more values in them, because if you have a lot of numbers that are very much alike, they would be grouped together. So there's not any strict definition of having so many values in a group, except for you have to have at least one. Or there's no definition that the groups have to be, have to have a certain range, a certain interval to them. So the whole purpose here of natural breaks, and this is why if you use like GIS or some other software, this might be a default, is it's good to kind of explore your data to see which breaks, which groupings group together things that are more alike, and try to create those groupings to also have the groups be as different from one another as possible. So you can see our 1 to 7s grouped together. I grouped 18 and 19 because they were similar. 23 seemed to be kind of on its own there. And then 27 to 30 seemed like they should be grouped together. So this is an example of a possible outcome of using natural breaks on our data set that we've been using as examples.